Hello and welcome to another tutorial. So this time around we are going to be making a time of day system, and we're going to be structuring this in a way where we'll have one core component that its focus is on keeping track of time. So it's going to manage how long our day is, it's going to manage our progression through that day, and then what it will do is it will output that time information and it can send it to a lot of different things. And so we'll set up a couple of different syncs, things that can receive that time information. So it gives us a really flexible way of setting up a time system that we can then plug in with other things. So I've used this before, this sort of approach for being able to plug into, systems for working with skyboxes, for in-game clocks, things like that. So we're going to take a look and see how we can get that up and running. So here's our starting point. I've created a scene that we will appropriately be able to see things like shadows and time of day and that changing in it. I have also, just so I've got it as a separate thing, set up a material that is using the Skybox procedural shader. This is a built-in shader that's available there. So I'm using that shader, and in our lighting settings, I have switched the Skybox material to that. That just makes it easier for me tweaking and adjusting things. I know that it's working with this separate material, and I would then be able to also set up custom shaders, stuff like that if I wanted to. But for now, let's get our time of day system up and running. So first thing we need something that's actually keeping track of where we are in time. This is going to be the central thing that's driving it. So I'm going to set up time of day manager. So its job is going to be keeping track of what the current time is, essentially. So let's get this set up. Well, first thing we want to have is our length of day might not be on Earth. Could be on another planet. So I'm going to have a field that controls the day length. Day length. Now I might default that to 24. And I'm also going to set up some tooltips for this. Length of a day in hours. Then I want to keep track of, well, what is my starting time? So serialize field, float, starting time. So we're going to assume we're starting at 0, so essentially right at midnight. So again, this will be the starting time in hours relative to midnight. So 6 a.m. would be 6, for example. So we've got our starting time. Well, then we're going to need to keep track of our current time, which we're going to assume, we'll just for now put that as 0. I will initialize a bunch of these things in awake. So in awake, that's where I'll be saying, okay, current time is equal to starting time. Now, other things might need to access this. So this is something where what I'm going to set up is make this a singleton. So public static time of day manager instance. So I'll make it that it's a private set on that. And then in awake, what I will do is if that instance is not equal to null, something's gone wrong. This means that we've somehow ended up with a second time of day manager, which should never happen. So we should treat that as a serious error. So debug log error, and we'll say duplicate time of day manager found on, and then we just output the name of the game object this is on. And then for good measure, to make sure that we don't inadvertently keep this one around, I'm going to destroy it and then do a return. Then I'll link the instance to us. So that works. So we've made it a singleton. We've got our current time. We're initializing that to the starting time. We have our length of day, which is good. Now with this, what I want to do is in update, I need to actually advance the time. But obviously in a game, we often don't want it to necessarily advance at real time. We don't want it to be, in that case, we want to have it advance at a particular rate. Sometimes we might want to vary that rate. So what I'm going to set up is a serialized field, and this is going to be how fast time progresses. And I'm going to call this the time factor. So if we think about this, I want time to pass faster. So what I could do is, if say I set this time factor to 60, I want that to mean that for every 1 second in the real world that passes, so 1 second for the player, 60 seconds or a minute for the in-game character has passed. So this, how fast, controls how fast time advances. Controls how fast time advances, e.g. 60 equals 1 real world second equals 1 game minute. Just so we've got a sense of how these actually work. So that's good. So then for keeping track of the time, it's not really a lot to it. Our current time, we add time.delta time by time factor. Pretty straightforward. But a couple of things that we could run into with this. So our time, we get to 24, we need to reset. So, okay, that's easy enough to do. What we can do with something like of that is we could say current time is equal to current time plus, and then if we wrap all of this in a modulus with our day length. So advance the time. Now what I'm going to do is I'm going to make current time here public for now, just so we can see it in the inspector, because I want to see how well this is working. Because one of the things that I specifically want to make sure I can do is, sure, going forwards in time is cool and handy and useful. Going backwards in time is also cool. And I want to have it that we're able to do that. So let's get our time of day manager into the scene. And starting time, I'm going to set the starting time to be fairly late. So 23.5 means we're at about 11:30 p.m. That would be equivalent to. So let's run this. And our current time didn't start at, well, it's a little hard to tell if it started at the right value. Let's change the time factor to 1 and watch this. So that's ticking up a little bit faster than we would expect. And that's because our current time, we're mixing up our hours and seconds here. So this is a really, really easy thing to run into because current time is in hours. So actually what we add here, time.delta time by time factor divided by 3600. That turns seconds into hours. So let's test with that now. We should see that it ticks over quite slowly. We can see it's ticking up slowly, which we'd expect. Let's change our time factor up to 60. That should mean that it takes it about 30 seconds for that current time to hit its cap and for it to tick over into the past 24, which is good. Like that's what we want to see, that it ticks over into 24. And then what we'll do is we'll stop it and we'll test and make sure that it works if time goes backwards. So that's the key thing, is that because understanding if the modulus is working correctly when we go backwards. So that ticked over as we'd expect, which is good. So let's set the time factor to be negative. So it's now negative 60. So let's run this. So we're going down. We would expect it to end up being something in around 23 point something is what we're looking for. So it's going to get to 0. And we'll see, and so it does go negative. And so it's keeping it constrained there, but it's not really changing the way that we need. So what we could do is we could do, common way that this gets handled is you do day length plus, because that way then it wraps it correctly. So this is a common thing that you'll see, because we're already doing the modulus, so adding it in for the positive case is not going to cause any issues. And the key thing is that we want, when we run this, we don't want it to go to like negative 0.0, we want it to go to 23 odd, which it did. So that's good. So we've got time able to move forwards and backwards. And we've got control over that. It's able to adjust the speed that's happening at, and we're keeping it bounded reliably within that 0 to 24 time period. Now we can start doing stuff with this time, because cool, keeping track of the time is very, very handy, but we want to do stuff with this. So what I'm going to do is I am going to set up another folder here. And I'm going to create a bunch of bridges. So we're going to have time bridge base. So we're going to have a base class that all of the time bridges inherit from. We're then going to have a time bridge for controlling the light. We're going to also have a time bridge for controlling the Skybox. And then the final one is going to be a time bridge that controls an in-game clock. So let's get this code set up. So this is a good case for where we would use an abstract class. We're not going to have anything in start and update, but we will have public abstract void on tick float new time, or current time. So that looks good. So every class that's a time bridge is going to have to implement that. So we'll start with setting up our clock time bridge. So it needs our onTick function, and it needs to say that it's overriding it. So the onTick one is going to output to a clock. Now, depending upon the setup that we're using, this could be outputting to a clock that has hands. It could be outputting to a clock that has actual sort of digital time shown. So let's get it set up for digital time to begin with. So using unityengine.ui. And I'm going to have serialize field, text, time display. So we need to format this time. So we've got hours that are there, and we need to get out minutes and potentially even seconds. Let's look at how we extract that out. So hours are the whole number for this. So what we can do is say, well, int hours is mathf floor to int. So a floor always rounds down, ceil always rounds up, and round goes to whichever is closest. So in this case, we want to use floor. So we do a floor to int of the current time. That gives us our hours. Then that current time, what we can do is say, okay, well, remainder is equal to current time minus hours multiplied by 60. So this is the remainder in minutes. That's why we multiplied by 60, so that it's going from hours to minutes. That means we can say, okay, well, minutes is equal to mathf floor to int remainder. Now we want the seconds. So, okay, well, remainder, we subtract, actually I'll do it this way so it's following the similar pattern to before. We do remainder minus minutes times by 60. That gives us the remainder in seconds. So now to format that time, we could say, well, okay, time display dot text is equal to hours to string, add in the separator. We could also go through other formatting options for this, but I generally prefer having the more sort of manual control over it. So we'll put in the hours. Now minutes to string. This, we want to ensure that it always has a leading 0. So if we do 0, 0 plus this padding again, and then we can say remainder dot toString, again, forcing in the precision there for it. So this should, we link this up to some text and it should output to it. We'll test and we'll find that out soon. First thing is our time of day manager. It needs access to these bridges. So we're going to give it a serialize field of a list of time bridges. Time bridge base, bridges. So this is the time bridges to send data to. And then what we do in our update is as soon as we updated stuff, we just go, okay, well, for each bridge in bridges, bridge, what did I call the function again? OnTick. OnTick, current time, update the time. So really easy for setting up and linking data to it, because we've set it up that you can have multiple things there. It means we could have a lot of different clocks or things like if that feeding from this data. So that means if I now set up just some really basic UI, in this case I'll put it down the corner of the screen. So we will set up a little panel. And I'll remember, make sure to configure the UI, usual sort of settings that I go for. This panel, I'm going to put this panel in the top left. And we'll just anchor it appropriately. And fix up the height. Don't need it to be ridiculously large. There we go. We'll add in our text under that. Time. Make sure that's filling out the whole space. A little bit of padding. Time is usually one of those ones where it being right aligned often looks better. In this case, because of how I've set up stuff, with that ensuring that there's leading zeros there, we shouldn't really need that. Plus another 8. That looks pretty good. Actually center that. Cool. So my time bridge, I've kind of got different ways that I could set this up, and I did this intentionally. I could set up the time bridge on this object, or I could set up the time bridge on the time of day manager. In this case, I think because it's controlling another object in the scene, I think it makes most sense for it to be on the particular object itself. So we'll link up the text, and then in the time of day manager, I can just add in that bridge. So what I'm expecting to be able to see now is that I can start this at 6 a.m. I can run this and my time will be being displayed here. So let's test and run this. So we can see time is updating. We've got our leading 0 there, which is correct, and it's keeping within the ranges that we would expect. If I change my time factor to be negative, it counts down, which is good. But because I've ensured that the data this is getting is always in that 0 to 24 range, it means this code's able to be simpler. And that's one of the key things with this, was ensuring that time, that data was passed through in a very simple way. We could also manage AM and PM conversions there if we needed to. We're not going to need to for this case, but we could do something like of that. So, okay, we've got a clock. That's cool. What about other things? Because we've got our light, and in particular, we've got our directional light here. So I want to be able to rotate my directional light. Now, this is going to be a little bit more involved, but still very doable. So if I go to my time bridge for the light, and that's again going to be based off of time bridge base. Again, public override void on tick. Now this is going to need a light to link to. So serialize field light. And there's going to be a few different things that I can be doing with this. So linked light. What I will do internally is I will say in the awake for this, I want to also be keeping track of its transform. Actually, I can directly access it through it. I don't need to do anything extra. That's all good. So I need to rotate this light based upon where we are in the time of day. So let's take a look at how this light works. So firstly, we'll leave actually, we'll put it to no rotation to begin with. So one option would be just rotating around X. We want to make sure that rotating around X would work okay. And in particular, if we've got a bit of a Y rotation, does that still behave sort of the way we want? So 0 is level, and then 180 is level on the other side. So we're kind of going between a 0 to 180 range with this light. That's what we're looking at for it. So we need to turn our time into that. Now, the challenge with this is, okay, if we're using Earth, we've got the moon and the sun. So, and at night it's not necessarily fully dark. So we might need to be doing a bit more there than just actually changing the positioning of the light. But what we'll do is firstly we need to take our time that goes from 0 to 24, and we need to get that to go 0 to 180, and actually then assuming things orbit in the same way. The other thing also, it flipping so it would be at 18, so at 6 p.m. So we actually need to have here serialize field float sunrise time, which I'm going to set to 6, and a serialize field float sunset time, which I'm going to set to 18. So now we need to classify this time of whether it's at night or whether it is daytime. So F current time is less than sunrise time, then we know it's pre-sunrise. If current time is less than sunset time, so we know it's during the day. Otherwise, it's at night after that sunset time. So we can start to get a regular sort of process position of where it is. Because what we're wanting to get from this is an overall progress value. Now, for when we're in that sunrise to sunset period, that's really easy. So if I have float progress, which I'm going to set to a very invalid value to begin with, but in this case, progress would be current minus our sunrise time divided by sunset minus sunrise. That's going to give us a 0 to 1 value of how far through the day we are. So that works for during the day. So during the day, this is pre-dawn. So in this case, well, what we need to do is we need our current time, but we need to also know our length of day. So we're going to need to be able to ask our time of day manager what that day length is. So this is where what I often would do for things like this is use underscores for these and then set up a public float day length, and that can link to day length. Just means other things outside of this can see it, but they can't change it. Because then what I could do is I could say, okay, well, our current time plus our time of day manager, it's day length, minus sunset time. That's our total position that we are at. And then we need to divide that by the length of our night, which is going to be this plus our sunrise time. So what I would do is I actually could cache some of these things. So a void awake. So float day length, or actually, daylight length, float night length. So daylight length is equal to sunset minus sunrise. Night length is equal to sunrise plus, we talk to our time of day manager to get this. I'll actually do that in start because we won't have anything coming through until then. It means that we will know the instance definitely exists. So we can divide that by night length, and that gives us our progress. So good so far. This becomes daylight length. And then this final one is going to be fairly similar. Our progress is equal to current time minus sunset time divided by night length. So now we have our calculations of this progress value, and we will know whether we are at daytime or nighttime. So that's good. So this is pre-dawn, and this is post-sunset. So we've got our progress, we know where exactly we're at. So what we can do is, if we set up a couple of other things, so a serialize field, let's have a gradient for light color day and one for at night so that we can really control how this is looking. So light color, night. And then we have our intensity we might want to change as well. So that I would normally use something like an animation curve. So we'll set that up as well. Light intensity, day, and a light intensity, night. That's pretty good. We can now work out which ones we actually use. So our progress, I'll actually go back to having these grouped like this, because that will let me say here whether it's daytime or night. So is night, I'm going to say false. Actually, no, I'm going to set it to true, because that way there's less ifs that I updated in. It's only in this one where I say that it's in daytime. Now I can update things. Because what I can do is I know that it's daytime or nighttime. I've got a progress value that's 0 to 1, and I've got things that inherently use a 0 to 1 value, which is great. So what I can say is, well, linked light, your intensity, if it's nighttime, then light intensity, night, evaluate, progress. Otherwise, light intensity, day, evaluate, progress. Similar thing for the color. So linked light, color, if it's nighttime, light color, night. Because gradients, you use a 0 to 1 value for them. So light color, day, evaluate, progress. So it gives us a really, really easy way of grabbing that stuff. So then the only thing we need to do is set the angle of that light. So I'm going to store vector3 light Euler angles. I'm going to retrieve the current ones. So that's our linked light transform dot Euler. And then it's the x1 in this case that I'm going to be changing. So the light Euler angles dot x. So okay, when I am at 0, I expect it to be at a 0 degrees. When it's at 1, it's at 180 degrees. So I can likely just do progress times by 180 and then set that back. Linked light dot transform dot Euler angles is equal to those new Euler angles. So let's test this out and see how this works. We need to make sure we update these ones that we modified. There we go. So we'll link up our bridge to the light and we'll configure it. So time bridge for the light. Link up the particular one. We'll also, our time of day manager, link that light up now like that. So it's got that time bridge. And we can set up, okay, our color during the day. Let's start the color at a fairly light blue. And then by the end, we'll put this at around 50. So 50 would be midday in this context. At that, we're going to set it to a bit of a yellowish white. And then at this point, we'll set it to a kind of a purplish, darker color. Actually, yeah, a little bit sort of purplish. I think will look good there. And then what I would often do for then configuring the other one is my starting point. I would often just copy that gradient and paste it over, because what I would usually do is make it so that these are kind of matching. So the entry point of one matches the exit of the other, just so that we try and make the transition as smooth as it possibly can be. Rather than being a sort of yellowish color at that point, it's going to be night. And again, that kind of bluishy purple is what I would sort of go for. And we could easily add in intermediate points, adjust how quickly it transitions, all things like that. Intensity, I'm going to keep it simple and just use a consistent intensity throughout. We could, again, tweak those values there, but we want to just focus on, okay, is this behaving the way that we want first? So let's test this out. Should see some lighting changes. So we can see it's trying to rotate. We can see we're definitely not getting the rotation sort of calculating the way that we would want, which is okay. What we'll do is we will take a look and see what's actually happening with that. So first thing we'll probably do is log out this progress value and see how that's changing, because we should see progress starting at around 0, given we're starting at about 6 a.m. and it increasing up to 1. It's what we expect to see with this. So you can see it started at about 0.5, which is higher than it should be, because our current time is incorrect. We accidentally put the starting time as 60. That would be definitely contributing some of the weirdness to it. So we'll make sure to fix that up there as well. So let's try this again and see. That should be a bit of a more gradual change. So that's looking better. And if we take a look at our light, that's also behaving better. Our angle is changing nice and slowly on that. And our color here will also change. If we actually do chuck in a bit of an intensity change, so let's make it that at dawn and dusk, it's sitting at around 0.25. It's pretty good. Same for this, 0.25. I'll just get that back. Cool. So then we'll chuck in an intermediate point here. And that at 0.5, we might make it be around 2, so fairly bright. So that looks all right. It's reasonably smooth. We could adjust how the transitions happen there, slow it down a little bit. Same for here. That looks pretty good. And again, copy, and again, paste that. But what I would do for the night one is, rather than it going up in intensity, what we'll do is that value will actually be even lower, so like 0.05. So if we test this now, we should see our intensity changing as well. You can see intensity is ramping up, which is good. If I adjust my time factor here, so at the moment it's passing okay at time, but let's make it even faster, because we want to see, let's make that faster again. So now it's passing quite quickly. We can see our shadows moving. We can see the tinting, the tone of the light changing as we're going as well, which is good. So it'll run through, we'll get to daytime fully. I'm going to make this even faster again. So hitting the peak of the day, it's getting quite bright. Our shadows are moving, they're now perfectly overhead. Now this is something that we wanted to cause to happen so we can see what's actually happening here with this. So this is one of the things where we're working with rotations. You can get into some issues with the behavior there for our Euler angles, especially when you're just doing sort of a setup like I'm doing with this. So I want to make this a little bit more refined how it works. And what I'm going to do is I'm going to actually set up, so we do a quaternion Euler, and we're going to do my calculation of the angle, and then we'll also have, potentially we could have values there for the y and z. For now we won't, but we'll use this. So the linked light dot transform dot rotation. Anytime you're doing a lot of stuff with transitions of angles, generally would recommend using quaternions for it. It's usually going to work a lot more reliably. So our time of day manager, let's get this running and we will speed this up again. So I have time flowing really quickly. I want to see if we receive the same problem. So we can see now it changes much more smoothly. And at night, it's a lot darker. We still get some of those shadows there, and we can see our actual sun appearance here is looping around. If we were looking up, we'd actually see it moving, which is cool. So, okay, we've got our time of day being tracked. We can go forwards and backwards in time. We can output that to a clock. We can output that to our light. Let's finally link that up to our material. So that's the final one I want to set up, our time bridge for the Skybox. So this is going to, again, be based off of our time bridge base. And again, we'll have that same function. Public void onTick float time, current time. And it needs to be override. So that's good. We've got our time there. Now, changing the Skybox is a little bit different to what you might have sort of seen. What we generally access is we have render settings dot Skybox, and then from that we can do things like set color. Now, to know what things we can change, if we take a look at our material for the Skybox. So our Skybox material, we can see we've got things like our sky tint, we've got stuff like the sun size, this exposure, which you can see exposure is probably a good one for us to be adjusting. So that, I think we can do a similar setup to what we did with our time bridge for the light. And I'm going to actually steal a bunch of this code because the similar settings would work. Because we can change tint color, we can change other aspects there. We do often want them to be different to what they are on the light. This is actually something that I learned from a friend of mine who's worked a lot on the art side of things, of having one color for your skybox, your environment, ambient lighting, and a different one for the directional lighting can really bring out the detail in a scene really well. So that's something I usually do these days, is kind of a bit of a purplish directional light or a purplish skybox light, and then a more yellowish light for the other one that I haven't set as the purplish sort of style of one. So that looks pretty good. So Skybox, so we know the parameters we've got. We've got exposure, we've got tint. If we go and take a look at the specific shader, then we can actually go and see. So if we select shader, we can see exposure is going to be there as a float. So we'd be able to do a set float, and that will be exposure. So that's good. And we'll also have our sky tint. So that's another one where it would be render settings dot skybox dot set color sky tint. And then I can actually use my same settings here, and it's going to be duplicated code a little bit. You could unify these into the one thing, but I would often have them actually a little bit separate because they are going to be using different settings. So I think if I combine them, I would end up actually having the exact same, like I duplicate the variables. So I'd save on a little bit of stuff, but not actually that much. So we'll get these linked up. So these are calculating colors, everything like of that. So all that would change is where we were setting the intensity, we'll be setting the exposure, and same for this color is setting the sky tint. So we'll bring this up to here. And then we just need to configure the data for it. That looks pretty good. Now we do need to put this on something. We don't have a direct thing for the Skybox. I would probably put this, in this case, either on the main camera, I think would actually probably be the most sense, or on its own standalone object. So I'm going to firstly link that in so it's receiving data, and then we'll configure the particular settings for it. So this, now I don't know if it's going to be smart enough to let me paste in the component values in this case, even though they're the same. No, but I'll paste in a new component, and then what I'll do is copy and paste in this manner. Copy, paste that in. Same with these intensity ones, although I will modify the intensity curves, possibly, because these are controlling exposure. So, okay, and we should actually rename these. So if I tweak the names of these so that they are proper, this is actually sky tint, just so we don't get confused. And oops, that's exposure. Sky tint night, exposure. Let's make sure we've got these in the right order. And the same on this one as well. That looks good. So these we just need to exposure night, exposure day. And then sky tint. And this, we'll need to chuck the data back in, which is okay. So we grab our colors, bring those over. We transfer over our intensities. And I might actually adjust, I don't know, that peak 2 might end up being a little bit high, so we might find that that needs to be brought down a bit, which is okay if it does. So this should be changing our Skybox now. So let's run this, and we could be changing other settings in there as well. So we can see, set that color, and let's up our speed of how fast time is passing. Sky's changing color, it's getting brighter as we get lighter in the day. gets really fast, gets really quite bright, so we could tone that down a little bit. But again, we get that nice sort of sunset effect and the sunrise. So we've got an extendable time of day system. We've got something where it's controlling lights and shadows in our scene. We've got something where it's controlling clocks, and we could be going and having that feed through into all different types of clocks. And lots of things can be receiving the data from it. There's one final thing I want to add in though, and that is we've got delta time that we use for a lot of stuff. We might want to have the delta time that we can ask for from this. The reason being is you might want something that it takes an amount of time, not based upon delta real world time, but based upon delta of the in-game time. So this is something where what I would do is public float delta time. So what that's going to be is time.delta time. And if we look at how we use it down here, it's going to be multiplied by our time factor divided by 3600. So the higher our time factor is, the larger that value is for delta time. So we can test and see if we've got our maths right there. What we'll actually likely find is that that needs to be swapped around. Pretty sure that that will need to be swapped around. But let's test this. And we can, in update here, debug.log time.delta time plus our delta time. This should be larger. So again, always when we're setting things up like this, we make sure we test it so that it's behaving the way that we expect, and we can see it's not, we're making it smaller, which makes sense. Because if you think about it, well, we did what we did down here with delta time and that worked, but that's converting it to hours and everything like of that. This, we actually probably don't want. Divide by the 360, because that's converting it to hours. We just want to times it by the time factor. Now that looks more like what it should be. So that means if we had something that is needing to work based upon delta time and based upon our in-game delta time, we can easily achieve that just by having it use our time of day system's delta time, which is going to be really, really handy. So we've got our key components. We've got our time of day manager that we can throw in and use for being able to keep track of time. We've got something that can display that time just as a nicely formatted value. We've got something that can control a directional light, both its color, its intensity, and also its direction. We're able to control that and link that up with the Skybox, so everything is in sync there. So it gives us a nice simple time of day system, and we have a delta time that we can access when we want something to use delta time, but use it based upon how fast time is actually flowing in the world. And as we saw, we can adjust how fast time is flowing dynamically because we've already got everything set up that handles wrapping, things like that. So we can just mess with that time and it just works, which is handy. So dive on in and experiment with it. The full code for the project, as always, is available up on GitHub, and you can use that code in any of your own projects, whether those are commercial or non-commercial ones. I've tried to set it up nice and modular so that you can add in additional things, additional time bridges if you need. So yeah, dive in and have a go with it. If you've got any questions, chuck in a comment below. And if you found the video helpful, please do chuck in a like and subscribe. It is something that really does help out and is very much appreciated. And if you're looking for other ways to support the channel, I do have a Patreon, and the link to that's in the description below. Bye.